Hello everyone and thank you for being here today. My name is Abhin Harshan Sendal and I'm excited to walk you guys through the technical deep dive into the Atherma database once again. So in our previous milestone we have executed EC2 instance as well as we created the database schema. All these things are discussed on the first milestone. Right now we are gonna move forward and deal with certain other things. So it basically this presentation covers several key aspects of our project, like focusing on how we have designed and optimized our database, especially for integrity, performance, and scalability. These three factors are much more taken into consideration in this project. Moving on to the next slide. So we are going to discuss what is the agenda of this project, or what are the key deliverables and overview that we are going to have in this project. So these are the things. So to give you an overview, we'll start with the MariaDB triggers, which I've implemented to enforce data integrity. Then we'll move on to the data partitioning thing. It is a strategy which is used to improve the query performance. After that, we'll shift to our focus to the conceptual analysis of NoSQL databases and their place in an e-commerce web platform. I'll also evaluate the MariaDB ColumnStore engine for analytical workloads. Finally, I'll conclude with a reflection on how I used an AI assistant to help with this project. So basically, I used ChatGPT as well as Gemini for an assistance throughout the project for certain needs. So that's it. So moving on to the next slide. So it is the MariaDB triggers slide. So let's start with what is a MariaDB trigger. So a trigger is essentially a storage procedure that automatically runs in response to a specific event on a table, like an insert or update statement. Also, we are using delete statement as well. So basically in this project, I designed two triggers for Atherma database to enforce critical business rules and prevent bad data from ever getting into the system, so that it will be good for the system and it promotes data integrity as well. So here we can see two examples which I've used. So I created one trigger, its name is before customers insert. So it is using an insert statement that is also before customers. So the purpose ensures that a new customer record always has a valid non-empty email address, preventing data integrity issues. So I'm making sure that whenever a customer is entering a data, it should contain a valid email address. It should not be null, or it should not be some other space character or anything. So operational impact is it's add a small amount of overhead to insert operations on the customer's table, but is a critical safeguard uh, against bad data. So basically it adds a small amount of overhead to the insert operations on the customer's table, but it is really a critical safeguard, because if you are entering bad data, it is going to affect our data integrity. So this will prevent those situations which are going to happen in real time as well. So another one is before products update. So what is the purpose? The purpose is to prevent a product price from being updated to a negative value, which is a critical business rule for any e-commerce platform. So we know that price can't be negative, and that is a basic common thing. So that is a trigger which I have implemented on the second example. So we can't enter any negative values. Okay, so operational impact adds a small preemptive check on update statements to the product table, ensuring all pricing data remains valid. So we will check whether is there any products that is getting updated with negative values. That is the second trigger which I have made. So this is a code and rationale behind the trigger implementation and analysis. So over this slide we can see this is a code which we have generated. So basically it will say that email cannot be null or empty. That is an error message that will be showing if a person is entering any null value for the email. Moving on to the second example here, this is the price cannot be negative code. That is the one which I've used as a second example. And these are the certain, this part is the analysis part, whether we are verifying if you are entering any customers with a blank email ID, it should throw another. We are checking whether our triggers are working correctly, and we are also implementing a positive case to make sure that the trigger is working correctly, and also a negative case, so that we will be understanding if the error is showing is correct, so that our triggers are successful. So both the cases have both taken a positive scenario as well as negative scenario for getting a good confirmation. So moving on to the next trigger. So basically what we are checking is the price cannot be negative trigger. So in this case, same, we are dropping the trigger if it exists and delimiter, and we are creating the trigger and trigger name, everything, and the condition is if new dot price less than 0. That means if the price is less than 0, then we are getting an error, price cannot be negative. For that also we have created a positive case and a negative case. A positive case is like the price is, we are inserting a product with these field names, product ID, product name, in which the price is a positive value. It is, I think in this case it's 10, so it will work. And negative cases, we are updating the products table and we are setting the price equal to minus 153, where product ID is equal to 18. So this case, it should throw an error. So I think I have executed it already, so I have a screenshot. So I think, okay, yeah, so this is the case. Okay, so this case you can see this is a positive scenario. We have given price as 10 and we are inserting, and it would work. It didn't throw any error and we are able to see the output. But for the other case, you can see that if we executed the second negative error, a negative case, it is showing uh, price can't be negative. Got it. So that is a thing which we want to say. Okay, so this is the first case, the positive case, when we execute the trigger, and I've added a comment, select star from customers, where customer ID is equal to 1667, and it is fetching the data correctly. Like, as the email is valid, it will not throw any error, and we are getting the output. So if we look onto the negative error case, I think I have also took the screenshot for that as well. Mm, yeah, I think over here we can see. So in this case, we have given blank value for this null value for this register what email. So in the second negative case, we are getting the error message that email cannot be null or empty. So these are the case which we created for the first trigger. So moving on to the next slide. Next slide is data partitioning. So basically, data partitioning is related to performance. I implemented horizontal partitioning on the customers table. Partitioning is a database technique that divides on single large table into multiple smaller ones. Since our customers table is expected to grow very large and we often run queries filtered by customer state, partitioning allows us to scan only a small subset of data, which dramatically speed up our queries. So uh, that is the reason which I've used customers table for partitioning, and the strategy which we have used is obviously we used a list partitioning on the state column. So this is perfect for discrete values like state codes, like as it have California, Florida, Texas, so many state codes are there. We can do partition on the state column. So moving on to the next slide. So it is the how we implemented the partitioning. So this is a code which I've used for implementing the partition. So basically, I've created partition by list column state, where the values in California, Texas, New York, Florida, and we should declare the column or the field which we are partitioning as a primary key as well. So I've given primary key of customer ID, which is the initial customer ID is the primary key of the customer table, and we have to also implement state as another primary key for the uh, customers table. So that is the thing which I have done here. So even in my MariaDB, I can show you. So I've saved it in partitioning 1.sql as a script. So basically it's the schema definition itself I have created and I've edited it. So in this, I think, yeah, the customers is the first table. So basically I changed the primary keys and I've removed the unique key as well. And I've also changed it to big int unsigned auto increment. Uh, so next is partition by list column state, and I've given all the values. So next we have to verify it is working correctly or not. That also I've done. Uh, that we can simply check by selecting count from stars. That statement we can easily check if that is working fine as well. So here you can see we are able to fetch the data successfully after partitioning based on the state. Okay, so that is about partitioning as well. Moving on to the next slide. So before that, I actually, this is the code which I've used for creating a partition table. I used basically a list partitioning technique that is also based on the state column. And for this, yeah, I think AI, especially ChatGPT, have helped me to run the test queries and analyze the results as well, which is of great help as part of AI. So now we are moving on to NoSQL concepts. So even though MariaDB is a great relational database, it's important to understand alternative approaches. Uh, so the rise of big data has led to the development of the NoSQL databases, which prioritize scalability and flexibility as well as performance. So this leads us to the cap theorem. So what is basically a cap theorem? It states that a distributed system can only guarantee two out of the three properties. So consistency, availability, and partition tolerance. So that is C stands for consistency, stands for partition tolerance, and A stands for availability. So NoSQL databases often choose availability and partition tolerance to ensure continuous service. So basically, these are the basic NoSQL concepts that we have to be aware of. So next we are going to NoSQL models and use cases. So it is key value and document models for Ethermart. So key value store. So basically what I have to say is like NoSQL is not a single solution. It's a family of models. For Ethermat, a key value store would be perfect for things like a shopping cart where we need very fast lookups. The document model is even more powerful for our use case. We could store all of our product details, including reviews and variants, in a single document, which eliminates the need for complex joins and simplifies our application logic. So that is one of the other variants which we can see other than this NoSQL as well. So now we are moving on to the MariaDB column store. So it is basically a specialized MariaDB storage engine that is called ColumnStore. Unlike the traditional raw-based InnoDB engine, which is best for day-to-day transactions, the ColumnStore, on the other hand, is a simply column-based engine designed specifically for high performance analytical-based queries. So this is a game changer for our business intelligence because it's optimized to read only the specific columns needed for a query, not the entire row. So basically, it will only look for the specific columns, not the entire row, which is of great use in terms of performance as well. So basically, we are going to look onto the column store use cases. So so this makes ColumnStore ideal for a variety of analytical scenarios at Ethermart. We can just check. We could use it for generate sales reports. Okay, so if you are asking a question like what were our total sales per month in 2024, we can use it, and we can use it for market analysis. For example, what is the average price of products sold in California? Or trend analysis. What are the top 5 selling product categories over the last year? Or data exploration as well. How many customers registered in each state during quarter 3? So all these questions are suitable scenarios where column store can be used and how it helps. So column store can answer these type of queries in seconds and where a traditional engine might take several minutes. So that is the advantage of column store use cases. So moving on to the next slide. Yeah, moving on to AI usage and reflection. So throughout the project, I've used AI assistants as a key tool. So basically, I used Gemini as well as ChatGPT for the help. So it helped me to generate and refine SQL scripts, and it was instrumental in debugging and fixing the syntax errors. It even helped me to figure out how to write test cases for my triggers and partitioning, which was a huge help. The main key takeaway is that while AI can provide a great foundation, I think human review and understanding of the concepts are still essential for a professional and accurate results. For example, the data partitioning part, especially, the AI is arguing to me that my database don't support what data partitioning, and it is constantly arguing that we can't implement this on my. I think my MariaDB is kind of an outdated model, so I can't use data partitioning on that. But but after careful observation only, I understood that it is because of a single semicolon that I didn't ignore. I had put a semicolon in a wrong place. That is the reason why it is showing like that. I removed the semicolon and it's working fine. So that is the case with the AI. It is really helpful, but what we need to also have some amount of knowledge in the things which we are doing. Then only we will be able to get good information from AI as well. So that is what I felt about the AI usage thing. So moving on to the conclusion and thank you. So thank you everyone for your time. This project has been a great learning experience, and I believe that this implementation will make the Etherma database more robust and performant. I'm very happy to answer any of your questions if you have. So thank you once again for everyone.